Okay guys, so here we have a question stating that a body is projected from the ground at an angle of 45 degree with speed of 30 meter per second. It landed at 50 meter from the point of projection on the ground. The decrease in the range due to air resistance taking g as 10 meter per second square. So basically first we need to calculate the ideal range, and for that we are going to use the formula. Remember this guys, this is the very important formula, that is range is equal to u square sine 2 theta by g, where u is the initial velocity. So basically our initial velocity is given as 30, so we'll also write for the given factors. We are given that u is equal to 30 meter per second. Also we are given that our theta is equal to 45 degree. Also we are given that g is equal to 10 meter per second square. Also we are given that the actual, okay, we might take into consider that later. First let's solve the problem. So let's go to the solution. So we'll take out our ideal range, that will be u square. I'm directly writing that is 30 into 30 into sine 2 theta, that is 2 multiplied by 45. This is basically going to be 1 by 10, because that is our g. So basically we get our ideal range as 90 meter. Remember, this is our ideal range. Now we are given that it reached, you can see it landed at 50 meter. So given range, that is r dash, is equal to 50 meter. Now we need to find the decrease. We need to find the decrease in range. So basically we will minus our ideal range with the given range. Therefore, decrease in range is gonna be r minus r dash, that is equal to 90 minus 50 meter, which is going to give us 40 meter, and this is our answer. So our answer becomes option number 1. Let's tally with our answer sheet. Yes, our answer is absolutely correct. That is option 1.